Howdy class, this video is on functions in Python. Now functions are a marvelous construct. They allow us to reuse our code in very rapid and efficient ways. And functions are common in practically every programming language that there is. Kind of a global best practice to get used to using functions and using them wisely and intelligently and efficiently. So we'll take a look at some of those things today, and I have plenty of sample code to go over. So here's a short summary of just what functions can do for us. First, this idea of modularizing our code is very important. Let's say, for example, that we have our main function and we're just coding like we always do. But let's suppose that we keep running into the same 3 lines of code over and over and over, just for whatever reason. Maybe it's a particular input area, or maybe it's a specific output area, or perhaps even some type of a calculation area. These 3 lines of code here will get very tedious to keep typing, won't they? Especially if they're the exact same thing. And then you get into copying and pasting and it becomes unmanageable in no time at all. And suppose that it's not 3 lines of code, but 30 lines of code that are constantly being repeated. Then it becomes really unmanageable. Let's say that we've got all this code that we've written here. And again, we have to take this code and we have to repeat it down here and then maybe over here again and down here. And let's also then suppose that there's a change to this code, maybe somewhere right deep buried here. For example, in this line, we have a change that we have to make. Well, if we had coded this manually with a lot of copy and pasting like we're doing here, one change like this little line here that we've got to fix suddenly is a burden to us, because that means we have to go and hunt for the code here and change that line and then keep hunting, and here it is again. There's the line to change and then another line to change. And this just becomes madness in no time at all. What functions will allow us to do is, instead of, here's our main function again, and instead of writing that code multiple times, we'll just write it once. So in other words, we will create a function, and all of that code will go into the function here. And in main, then we will just call that function whenever we need it. It's like the function sitting over there in the corner, and it's time to wake them up and say, okay, I need you to perform now and do your tasks. The function will wake up and do their tasks and then kind of go away. We can call that function repeatedly in our program, not just here, but maybe later in the program, we'll call that same function here, and maybe later, we'll call it a 3rd time. So this is the idea of modularized programming, where we have our code broken into rational, logical chunks, logical blocks of code, and we just simply reuse it whenever we need to. That's the whole idea behind functions. So modularized code is just a huge benefit. It's absolutely simpler to code this way. You saw the example that I just kind of stepped through, showing that if we've got a change to make, then it's a hassle to make that change 5 or 10 or 15 times. Instead, why don't we just make the change once? We'll just put all of that code into a function and then just call it whenever we need to call it. So very simple, it's reusable, call it whenever we want. Also, it's easier to test, and that's because we can isolate a function and just simply test against it. Makes it quite easy. Faster coding as well. The books mention that. The book mentions that, and you can imagine all the time saved for not having to repeat this code over and over and over and over. And then finally, using functions is again a global programming best practice. You want to maximize your use of functions always, and your team will appreciate you when you're coding in your first internship or in your first development job. Your team will appreciate you because you are coding in functions, and I'm sure that company policy is going to be to use functions as often as possible. Now in Python, there's 2 types of functions. This week, we're going to look into void functions. And then next week's content is all about value returning functions. We'll spend a total of 2 weeks here in chapter 5 in the book with Python functions. And what these are is a void function is one that we can simply just call to perform some type of a task. So let's say that we've got our main program here, and then we've got some function called over here or defined over here. A void function is one that we're simply going to call to execute a task. Maybe that task is something as easy as show menu. Maybe it's something a little more complex like calculate revenue. But what we'll do here is just somewhere in our main function, we'll just call it. We'll call some function. And it will then right in that spot, it's going to take all of the function definition code that we did and essentially, put it right there and execute this function. It's called a void function because it doesn't return a value. Now, we'll get into this next week, but functions can also return values. After we have some coding here, we can have a return statement. And for example, return value. And what this does when the function is called, it starts to execute it. But when the function ends, this value here is returned to this function call here. And we have to store it or print it or do something intelligent with it so that that value gets stored. It'd be something like this. Value equals some function. Some function is the part that will execute over here. This starts to execute. We get all this processing happening. Finally, we have a value that's going to be returned. This value gets returned here and then assigned to whatever this variable is right there. So that's the idea behind a value returning function. But for this week, again, we're just going to use functions that are void or non-returning, non-value returning. Okay, here's a very short example of a function. Now, we start a function definition with the keyword, the reserved keyword DEF, and it stands for definition. So we're going to define a function here. So there's our keyword there. Let me change a pen color. And then following that, we simply put the name of the function that we're creating. And this is programmer defined. You can use anything that you want. We do want to get into the habit, though, of making sure that our function names are named something that's descriptive of the tasks that they do. So remember that, and I'll be kind of grading you against that as well. If you have a task that you need done for calculating revenue, well, then your function name should be calculate revenue. It shouldn't be something like CREV. Because what is that? CREV. If your coding partner or your team looks at that and says CREV, I don't understand what that is, it's not a word, then you'll get some pushback for it. That's why we want to make our function names very descriptive about the tasks that they perform, okay? You'll know that it's a function definition because we have these open and closed parentheses again, like we've seen all semester quite frequently. Anytime there's a little method or function that has to get executed, well, then it'll have open and closed parentheses. In just a few minutes, we'll show what goes inside those parentheses if we decide to send some arguments to the function, but we'll get to that in a minute. Here then, after the function header, then we just put whatever code we need. And here I'm just going to do print hello. Now then, to call this message function, all we do is simply write the name of the function message. And don't forget the open and close parentheses because it'll give you an error if you don't. And this will just execute the way we would expect it to. The interpreter, the Python interpreter, is going to go line by line. And here at line 1, it's going to say, okay, here's a definition of a function. Line 2 is some of the content inside that function. But just because something's defined doesn't mean it's going to run. We have to specifically call the function in order to get it to run. So as of this point here, the function has not run. It's just been defined and loaded into memory so that the interpreter knows what to do when the time comes that we get a valid function call. And then here you go. There's our function call on line 3. And then all of this code will finally get executed. Now I have an example to show you, and let me shift back to Jupyter Notebook and demo that. Here we are with program 5.1 from the book, and it does exactly what we just did on the board. We create this function definition called message and put a couple of print statements inside it, and here we call it. So let's run this, and as you guessed, it's just going to simply print out the contents of the message function. If we didn't call this, then the program would still run, it just doesn't do anything. So this demonstrates that just because we've defined a function, that does not mean that that function ever gets executed. It only gets executed when it's called. So get used to that term in computer science, calling a function. It's a very specific act, and all programming languages have that construct where you call a function and then it goes and does it. So let me back out of, oops, I don't do that. Let me put this back in. And now it runs just properly. And you can see here, we could do quite a number of things here inside here. Run it again, and it'll output then all of that stuff. Okay, so this is the simplest form of a void function, simplest form. Okay, here's a new program structure that we'll be starting to use this week. We have been coding without knowing it. We've been coding all this time a main function. And a main function is exactly that. It's the main function that gets executed when the program starts. The compiler is going to look for it. And what we'll do is get into the habit of creating a specific function definition for our main function, and then calling the main function at the end of our program. So this is the new structure that we will start to use in our coding. If this is a typical Python script, maybe it's one cell in our Jupyter Notebook, or maybe we've busted it up into some different cells. We'll always put the main definition first, starting with def main, and then that's where we're going to code our program. Then whenever we have these functions that we are defining as part of the user or programmer defined function writing, those go after main. Okay, so main first, then other functions, and then finally at the very end, what we do is we call main. And this looks like a valid function call because it's got the name of the function here that matches this right here. And we've got the parentheses, so it's simply going to execute that function. So here's some code that will show that, and let me shift over now to it. So here's program 5.2 in the book, and you can see here that, all right, our structure is different from how we coded before, but it's just like we drew on the whiteboard just now. Here's a main function. Here is a message function, similar to what we just did above, and then here's a call, main. So the interpreter is going to read this and go, okay, I understand that, it's just a function. Okay, I understand that, it's just a function. And then it's going to look for something to do. So it's going to hear execute main. So now then control goes back up to line 4. It's going to print that out. Then we go to line 5. Hey, and line 5 is a function call to the function message. So execution will skip from line 5 now and go down to line 10 and print out that stuff. Once line 11 is done, then execution goes back to the main program where we just left off, and we'll then get line 6 printed out, and that's the end of the main function. So when we run this, you see here that we've got these messages in this order. Now I'm going to change these. I'll change these strings to just 1, 2, 3, 4 and run it again. And you can see here that the order that these things are actually output is 1, 3, 4, 2. Well, let's make sure we understand why that order is the way it is. So again, nothing gets executed with these function definitions that we've written. The only thing now that gets executed here is main. That means we go to line 4. That's where we get the 1 output. Then we go to line 5. That's a function call. So now we jump to the message function, and we will get the 3 output, then the 4 output. And then as you see here, the function is done. So control goes back to the main program right where we left off. So it's going to be the line after this function call. And that's where we get the 2 output. So now that sort of makes sense that we get 1, 3, 4, 2 output in that order. So this is going to be a very typical way from now on that we will create these, create our code. Again, always put main first, always put main first. Now here's program 5.3 in the book, and it's very simple. We're just outputting a bunch of text, and let's trace through this and make sure we understand how it is written and how it's intended to be executed. So here we've got a nice healthy main function with some comments to tell us, what we're doing. It looks like we've got a function here that's called startup message. That's just going to be like a little welcome message. Then it looks like we've got a step 1, a step 2 function, a step 3, and then finally here a step 4. And then, as we might expect and hope for, we've got the main definition or the main function call here. So let's trace this out. We'll start with main. Let's go up to main. All right, the compiler will look at this line of code and say that that is a comment, and then it'll execute startup message. So from here, we jump to startup message, and then these 4 lines get output first. This is done, so we go back up to main, right where we left off, and do the line after startup message. And then that's going to be this line here. Input, press enter to see step 1. Once that's done here, we have another comment, but we call the step 1 function. All right, so it's called, it means we jump to it. Let's jump down to step 1. Here it is. And that's simply going to output those 3 statements. Once line 33 is done printing out that new line character, control goes back up to main, right where we left off. That was our function call. That's complete now. So now we're going to go to line 10, and then 11, and then 12, where we have another function call and another and another. Okay. So let's run this. And it's kind of a cool little function, or a cool little program where we just hit enter in order to see step 1. There is what output after I hit enter. And now I'll hit enter again for step 2, 3, and 4, and our program ends. And we just got this how-to guide for setting up a dryer or disassembling a dryer. So this shows how to code multiple functions in your scripts. And again, you will want to always have your main definition first, the main function call last, and after your main definition, that's where all of your other function definitions go. Okay, let's talk about local variables now. Local variables are just variables that reside within a function. That's it. However, they remain in that function and only in that function. In other words, we could say that the scope of the variable is just that function. And what do we mean by scope? Well, we're talking about, well, is the variable accessible, manipulatable, whatever that word is? Is it available? Can you access and print it outside of the function? And for local variables, the answer to all of that is no. The scope is only within the function, and once the function ends, that variable goes away. It actually is destroyed by the interpreter. Once the function ends, all local variables get destroyed. So what does this mean here? Well, I've got some simple code here that has got a main function where all we do in the main function here is call another function called getName, and then we print out that name. So when we call getName, now we go here and we see that this has got a variable created in it called name. So that name is a local variable. So all of these rules apply here. It does reside in a function. It's going to be local to that function. The scope is the function. It's not visible outside the function. It gets destroyed as soon as the function call ends. So the issue here is that when we try and access here in the main program, we're trying to access the variable name, right? Because we're just trying to print it. We're going to draw an error because nowhere in this main function does there exist a variable that's named name. There is no name. So it's going to draw an error. Well, we would think in our coding mindset that, well, this function, though, has got this definition of name right here. So what's the big deal and what's the problem? Well, name is a local variable and all of the above rules still apply. The way around that is, well, we could create a variable name here and then we could sort of get around the error, but we wouldn't have much use for that because we can't quite yet get our name variable here from the function back up to our main function. And we'll do that next week when we talk about returning values from functions. Now there's some good code for that. Let me go to that now. And this is what we just, demoed. And you can see here, as soon as I enter a name, I get a lot of very ugly red and green and black and text and blue, and we get the error here that name is not defined. And again, that's because here in our main definition, there is no variable named name. In the scope of the main function, there's no local variable name. Just like here, in the scope of the getName function, there is a local variable, but it gets destroyed as soon as getName finishes. So by the time this getName function call finishes, that variable is destroyed, plus we can't see it anyway because it's out of scope. So that's the error we get there. So just a word of caution about local variables. They can cause errors. We have to be very aware of them, and we will be then passing these various variables back and forth between the functions in order to get these things to work. Okay. Now here's another program from the book that talks about global or local variables. This program 5.5. So let's just look at this and try and understand it. First, way down at the bottom is our main function call, good. Let's go right to our main definition, and we see that it's comprised just of two function calls. We have a Texas and we have a California function call. First, a little editorial note. Maybe I'll email the author, but having a function named just Texas and a function just named California is not good naming practices because it doesn't describe what the function does. Our function name should be descriptive of the tasks that they perform. So Texas is not a good one here. I'm going to replace it actually with show Texas birds, like that. And I'm just going to rename that. Same thing here. Show California birds. Oops. And now that's a lot better because it is naming our functions something very descriptive. Okay, so the first thing we see is we go to show Texas birds. So let's look at that. Here's the function definition. Now we have a simple local variable called birds. The scope of that is only within the function. And you can see here, then we have a print statement that has the birds in it, okay? Let me do a little bit of alternate coding. Do a little bit of alternate coding like that, just to take advantage of the F strings that we print out. There we go. So this is showing that here in Texas, that local variable birds is going to stay right here. And once this function completes, birds goes away. Then we call California birds, and it has its own local variable. This local variable and this local variable, even though they have the same name, they are completely separate variables in memory. They're created separately, and they represent different memory objects, even though they have the same name. Well, why can we do that? Well, you can name variables the same thing, as long as the scope is different. So in this case, the scope is completely different. We've got these two standalone functions, and we just call them separately. So there's the output there. Texas has got this many birds, and California has got this many birds. Okay, now let's look at passing arguments to functions. So suppose we have a function over there in the corner, and we need them to perform a task. But in order for them to perform the tasks there, they need a piece of data. So what we're going to do over here in our main function is we've got this piece of data, and we are literally going to send it to that function. We're going to toss it to the function. They'll be over there, they'll catch it. Now they have a piece of data that they can operate with, and they'll go and do whatever operation they needed to perform, whatever we tried to code. So this little schematic here hopefully will demonstrate that process. So here's our main function here. We just have a value variable set to 5, an integer. And then I'm calling show double. Show double is the name of this function right here, of course. But now look what I'm doing rather than just having an open close parenthesis. I have actually put this variable name in between the parentheses. And just like we saw with the many functions that we've dealt with so far, this is just, we're giving it an argument, okay? So the show double is going to have the argument of value. And what this is literally going to do is send the value 5 over to the function, okay? It's going to send it to the function. Now, what this 5 does is over here in our function, it gets sort of renamed. Check out this right here. In the function definition here of show double, we don't have just the open and close parentheses, but we have our parameter there. And we can put a parameter name in there, num, and num can be anything that we want. And it doesn't have to match anything up here in the main program. It can be anything. Because what happens is when we send this 5 over to the function, it gets renamed as num. Okay, so now anywhere in this function where we have num, well, that's just going to be the value 5, and it's going to then do whatever operations it needs to on that. So this process is easy to understand. The nomenclature can get confusing. Let's go over that nomenclature real quick. First, when we send an argument to a function, in our function call, let's say that our function is just called do stuff. Doesn't matter what it is, just do stuff. And we're going to send two variables to it, A and B. So when we send these like this, these are called arguments. And it sort of makes sense, what arguments does this function need? And these are the arguments that we sent to it. So it's sitting there in the corner, we're going to send it A and we're going to send it B as arguments. Now on the receiving side, they're called parameters. So in our definition here, and this is the definition of the function, here I'll call them val1 and val2. These are the parameters. These are the function's parameters. So when we name them here, they're called parameters. And you guessed it, when these get sent to the function, when A and B get sent to the function, they are sent, if we have two variables, they are sent in order. Okay, so A goes to there and B goes to there. So that's how the mapping occurs. A is now val1, B is now val2. And then within this function definition of do stuff, we can use val1 and val2, and they will receive or retain those values of the incoming parameters. Okay, so arguments and parameters, just remember argument is on the function call side. Here I'm throwing you some arguments. Parameters, the function is going to receive these and call them parameters. Okay. Well, let's take a look at a little bit of code that will demo this. And here is program 5.6 in the book. And let's just look at it. Okay, here it is. We've got the main function call here. Here's our main definition. We've got a value here. So a variable that's assigned the value of 5. And then we are going to send that 5 or send that value variable as the argument to the function show double. Okay, so that gets sent here. It gets renamed temporarily to number. And then you can see here that we just have some simple operations. We create a local variable called result, and there's a calculation, and then we just simply output it. So you can see here, the output is 10. If we change this to 150, it doubles to 300. So you get the idea here of throwing these arguments to a function. And you can do that with any data type. You can send a string, a double, a float, an int, a Boolean. We can send anything we need. Hey, there's my dog. She just checked in on us. I guess she saw me talking and got scared. All right, there's one more program that I would like us to take a look at here, and this is a good one. This is program 5.7 in the book, and it's just a conversion program, converting cups to ounces. So let's go over this and see if we can try and understand this. First of all, here's the main function call, so we're good. That means that this then will get executed right away. Let's step through it. Okay, intro. That means somewhere there exists a function named intro, and here it is. So now we're going to call here, and we're going to execute these 5 lines. Okay, and intros just looks like it's going to print out just a little banner of some data. Okay, intro is now done. Any local variables get destroyed, and we go back to the main program to the line after the function call. So there's the function call. Now we go to the line after. Okay, it's just a comment. And here we go. We enter the number of cups. Then we have a function call here, cups 2 ounces, and that's a really good function name. And we send that variable value, cups needed, to the function. All right, so now let's trace that out. We're going to go to cups 2 ounces. So here it is. We go to the first line of the code. We see that the formal parameter name here is cups. So we just do this simple calculation here. We have a local variable called ounces. And that will then, output here once that conversion's done, and we get a nice conversion. So let's see, 15 cups, how many ounces is that going to be? 15 cups is 120 ounces. Who knew? Imagine that. Life is good. We have a really good cups to ounces converter here. Now, this next program that I wanted to demo here from the book is one that's going to show a function call with 2 arguments, not just 1, but 2. Now, you remember we just saw on the whiteboard that we can send any number of arguments. There's no limit. And those are then mapped to the formal parameters in order. So here we have this show sum function call, and we're sending it 2 integer literals here, a 12 and a 45. Well, those then get mapped here in the show sum function. Those get mapped as num1 and num2. So now 12 is mapped to num1 and 45 is mapped to num2. And then we just output the results there. So there's the result, 57. The key takeaway for when we're sending multiple arguments is just that they get mapped to the formal parameter names in order, okay? And then here is another function or another program that is simply going to use strings instead of numbers. And everything works still just the same. You can send strings. Here's the reverse name function, and we send in a couple of strings to it. Those get mapped into the function as these names first and last, and then we can use those to manipulate or whatever we need to do. So let's run this. And there's my reverse name, Dietrich Mark. All right. Okay, here's one final program that we'll take a look at. This is program 510 in the book. And this is just going to demonstrate how if you try and change something, you can change it if that variable is in your scope. If that variable is not in your scope, then you can't change it. So let's take a look and see what's going on with that. So here's our main call. Go up here, value. Okay, we have a variable that's an integer called value, and we assign it 99. And here we just output it. So here we're going to send that 99 to the change me function. So we get sent here. Value then of 99 gets mapped to the formal parameter name of arg, A-R-G. And then look what happens in line 12. We attempt to reassign arg as 0. And that's fine. You can do that. Then here we output what the new value of arg is. Then that function ends. So we go back to the main program, to the line after the function call. And here we're just simply going to output again what value is. Now, our minds might think that, okay, this code is actually going to change the value of 99 to 0 for the whole program. But we'll see that, nope, it only changes it within the function. In the main program itself, since value itself was never changed, we'll see that value remains as 99. So here's the execution now. And let's map this out. First, here's the first print statement. The value is 99, so that's what we get here. Then we get sent to the change me function. So that's here. We print out, I'm now changing the value. And then we print out, okay, the value is now 0. So we get that, the value is 0. But then look up in the main function. When we print out this statement, we get 99 again. And again, that's because arg here is just a local variable. Its scope is that function only. and we can't access it anywhere else. Up here, value was sent to the function. It's like here function, catch, I'm sending you 99, but that does not change the value in main. We'd have to get a value returned, which is what we're going to learn next week. So hope this helps, and keep watching a couple other smaller videos with just some tips and tricks, and then good luck on this week's assignments. They'll be hopefully very good to just kind of cement this structure of getting functions declared and properly passing variables back and forth and stuff.